What are surds and why do we use them? Well, surds are simply the square roots of numbers. And there are some numbers, for example 4, if we are to square root it, we get a nice integer for the answer. However, there are other numbers which, if we are to square root, if I'm to punch that into the calculator, what actually comes out is an irrational number which just carries on and on. It doesn't end. It's a bit like pi. So for accuracy, we'll often keep our answer in surd form. I'm just going to go through some examples of how we can rewrite our surds in order to simplify them. So if we take root 4, I can break the 4 down into its factors, which is 2 times 2. This can then be rewritten as root 2 times root 2. Notice I don't need to put the multiplication sign in there, that's assumed. This is root 2 times itself, or squared. Now the square and the square root are the inverse of each other, so they cancel each other out. So we end up with the answer of just 2 again, which is what we expected. Square root of 4 is 2. Let's take another example. Let's look at the square root of 12. We could break this down into factors 6 times 2. But this is actually not going to be very helpful to us because the 6 on its own and the 2 on its own, we cannot actually square root those, which is what we want to do. We want to find factors of square numbers, and your square numbers, if you remember, are 4, 9, 16, 25, and so on. All the numbers that we can square root. So instead of 6 times 2, it would be much more useful to us to break 12 into its factors of 4 times 3. This can then be written as the square root of 4 times the square root of 3. And the square root of 4 is 2 root 3. And that's the simplified form of root 12, 2 root 3. Okay, so let's look at another example, which is again a little bit more complicated. Let's look at taking root 75 and adding square root of 12. Now what we're going to do here is we're going to break our 75 down into factors, and remembering that we're looking for factors which are square numbers. So hence I'm going to choose 25 times 3, and the 12 is going to be the 4 times 3. This becomes root 25 times root 3 plus root 4 root 3. The 25 we can square root, so we've got 5 root 3. The 4 we can square root, and we've got 2 root 3. Now, the root 3's here are like terms, and we can collect our like terms together. So we have 5 root 3's here, plus 2 root 3's there, so in total we have 7 root 3's. Another example, I'm going to look at 2 root 7 all squared. Now the square means that we have got 2 root 7 times 2 root 7. Now because multiplication is commutative, I can actually write this in any order that I like. So I'm going to write the 2 times the 2, and then times root 7, root 7. So that's going to become 4 times root 7 squared, and as we know the square and the square root cancel each other out, so we end up simply with 4 times 7, which is 28. Okay, another example. Let's look at minus 2 times the square root of 300. So again, I'm going to break my 300 down into factors, and I'm looking again for square numbers, of which 100 is a square number. So factors 100 times 3 is perfect. And that's going to equal minus 2 root 100 root 3. 100 square rooted is 10. And now we can multiply our integers together. So we've got minus 20 root 3. Let's look at an example using a bracket. So I'm going to have the square root of 6 outside of square root of 3 minus 2 root 2. Now what's happening here is that the square root of 6 is being multiplied by every term inside of the bracket. So the first one it's going to multiply is the root 3. So we get root 6, root 3. Then we've got root 6 times minus 2 root 2. Now, again, because multiplication is commutative, the way I'm going to write it is I'm going to put the integer first. So it's going to be minus 2, and then it doesn't matter whether I write the root 2 or the root 6 next. Now, what we've got here is root 6 times root 3. I can't square root either of these, but sometimes we can actually combine them. So I can write that as 6 times 3 minus 2. This is going to be 2 times 6. And 6 times 3 is actually going to be 18 minus 2 root 12. So although I couldn't do anything with the root 6 and the root 3, now that I've got square root of root 18, I can break it down into other factors that I can work with. So 18 can be broken down into factors 9 times 2. And root 12 we've already worked with, of course. So our root 9 root 2 minus 2 times root 4 root 3. Root 9 is 3 root 2. 2 times square root of 4 is 2. So we've got 2 times 2, which is 4 root 3. Now we've got a square root of 2 here and a square root of 3 there. They are not like terms. So we cannot combine those two together. They have to remain separate, and that's as far as this solution can go. Now the last example is probably the most important one. I'm going to look at the difference of two squares. So we've got two brackets here multiplying each other, and the two terms in each bracket are the same. So I've got root 7 here and root 7 here, root 3 and root 3. The only difference between the two brackets is the sign. This is negative, this is positive. These two brackets are known as the conjugates of each other. One is the conjugate of the other. Now, if we multiply these brackets out, we're going to get root 7 times root 7. We're going to get root 7 times root 3. We're going to get minus root 3 times root 7. And we're going to get minus root 3 times plus root 3. Now, I'm going to rearrange the order of this because this is multiplication and it's commutative. What I'm going to do is I am going to write out this term in the opposite order. Minus root 7, root 3, and we've got root 3 squared again. Now, I've done this so that you can see very clearly that this term is exactly the same as that term, but you've got a plus and a minus, so the two of them cancel each other out. So what we're now left with is our root 7 squared minus our root 3 squared. And this is where the expression, the difference is the minus, difference of two squares. And it's the first term of the brackets squared minus the second term of the brackets squared. And if we work this out, the square and the square root cancel each other out, so that becomes 7 minus 3, which is 4. And the nice thing about difference of two squares is it always yields a nice integer answer, which is very useful in our further work with surds. And you'll see it in the next video where you are rationalizing the denominator of surds.